this is a very small talk. Why use WebAssembly? If you don't know me, my name is Miguel. She already introduced me. I'm an independent web developer. I'm from Venezuela, but I'm living in Colombia. I was a university professor, and I've been in a lot of communities, and I've been in the Mozilla one. And that's why I'm going to talk about this topic today. So, since the beginning of the web, the explanation, I'm having two problems since the beginning. The first one is if you want to have this application or interaction with a user, there's only one with JavaScript. If you want to do some app or some dynamic web page, you need to be with JavaScript, and that was the only way to do it with that type of application. But even though JavaScript is a very good language, has limitation. So therefore, the web was limited with all the possibilities of JavaScript, and these had problems. Another problem was performance. Due to the nature and the language, this language was not designed to be very fast, but to be to the performance. So that's why the performance is not excellent, but the ones that develop browsers as Edge, Firefox, Google, they have more and more tasks, so this can run faster. But the downside of this is to optimize the platforms. There are limits. For example, native speed. We cannot go as fast as that. Why? Because when the browsers execute JavaScript, is something what you are talking with another language that you don't know, and you have an interpreter in the middle. So you know how this works. That you talk, the interpreter receive the information and then translate it or interpret in the other language. And this is kind of slow because there's someone in the middle, and it's about seconds behind. So as JavaScript, this code is and it's the same with the interpreter read it and then goes to the other side, so it's a slower process. So let's see some examples. So most common is, for example, in this addition is something in JavaScript is what we are looking in this slide, in this screen, and we have variables a plus b, and you can say, well, this is simple. And also, we need to instruct our CPU. So in JavaScript, this is not the case. This is a document that defines the structure of how this must function. And this is 6.1. And this is composed of 7 steps. So if somebody wants to do something simple with just command, it says 7. Because with JavaScript, we use the plus operator, not only for addition, but images or text. So when two variables are united with the sign of addition, you need to check the variables. And then the second one, verify that combination in order to know if the addition of two numbers or to concatenate. And in a cycle, we are going to see that this unique instruction is from 1 or 2, or in a cycle, it will be 1/800 slower. So that's why it's not as fast as other languages. There are other things that for Java is normal, for other languages is odd. For example, in JavaScript is this change, or this is 0. But why, if this type is like a number, is equal to 0? It's some problems. Or objects or variables in this type of empty strings. And these are these details that are very specific with JavaScript. But how can we solve this? It's simple because we have WebAssembly. It's a way to embed with browsers in common, a way to execute in your browser or platform this code in different language, different than JavaScript. So if you have a piece of code, you have the assembly, but you can execute in Firefox, Chrome, or any other platform that support WebAssembly. And the advantage is a binary format. It does not substitute JavaScript because many people think that is one or the other. No, it's to complement. So there are two puzzle pieces that complement each other and they support each other. They have interface through languages. So I can do my explication in Rust and then my code in JavaScript and then Go and vice versa without a problem. So they can communicate each other. So there is a total integration with Web API. And this means that with GL from Automatic and I use the API of WebGL, or if you are working with the audio, you can use Service Work. Everything that you do in the web, you can do it. It supports a different type of instruction and variables that JavaScript doesn't have. Some operation like SMIT, and this is using in the video. So with this same instruction, you can apply the same code with a lot of data. It's very easy to compile. And the WebAssembly, you can listen. And there is retrocompatibility. And with this new version and revision without a problem. And also works with 1 byte memory blocks. And with the browsers, it's like two people are talking the same language. For example, when somebody from Mexico and somebody from Venezuela, and we can understand pretty well. There are some details that the Mexican can say, this food is very cool. Well, for us, maybe cool, we use a different word, but it can add a little bit time, but it's faster comparing with the interpreter example. So WebAssembly is in a binary format and image code. So JavaScript reads that, executed, and that process is faster compared with the other one. And currently, this is supported with the main browsers. It's one of the few technologies that decided to bet and work in this. So with this, you can use it in all the formats. Then let's a binary format is this one that we are going to use. You download and execute it in the JavaScript machine. The first 4 bytes will have the binary and then another portion to the code space, another one in the variables, and it's an executable piece. This is another format called WAT, and this is a text format, and it's a low-level program, and you can use it in an environment that is very security. If you don't trust the compilators, you can use it in this one. So how can we create this? There are some language that are supported with this, with a compiler, and I will create the archives or the files. In Rust is like this example. We have the WASP, and we can transform the Rust code to the other one. Another one is with mscripting. Is another one that is called LLVM, and then we have this virtual machine and work like this. With mscript, we can have with different tools and then create this one. and we just need one command with this. And there's another project, external project with Java, and we can change from one to the other. So once you compile through this method, you will find a binary file that is already compiled, and then the JavaScript file, and then upload this code.js in model. And from there, I can import it and use it as any other model in JavaScript. And the third file is the HTML web or page and execute everything. The other is you can interact with the code. You can create a piece of code with Rust and then other function and vice versa. And the process is like this one. In C is like a library, and then the external library, and then JavaScript import the model, call the function, and you can execute the code very easy. And vice versa, there are some function or library where you can execute that JavaScript code without any issue. And the Rust is the same. What can I do with in the web? We can create high yield apps. In the case of, this is an example of a filter. Well, during this pandemic, we need to improve our aspect, and we can create apps like Snapchat, like through filters. We can use WebAssembly, scan images, and work faster. So in filter is 200 up to 2000 faster with compared with JavaScript. And you can replace, for example, WordPress, the editing part, change it because the performance was better 300 times. 1 second in WebAssembly took 5 minutes with JavaScript. So that's why if you need this, WebAssembly is perfect. Another example is with Google Keep. What is this? Well, you can see this demo. I think this is reproducing. And you can take notes. This is an app, but this is in C, and instead of writing from 0, you have the data, input data, and then transform it to a canvas. Google Drive uses WebAssembly in order to execute this code. Another thing is to migrate app easier. AutoCAD migrate to web, and what they did was this code of the 80s, and with using this code, and is there in C++, and they have it to the web through WebAssembly. It doesn't matter if the code was so old, and they just did some steps like this with this new platform, and not to rewrite it again. We have this demo. I save it in a 2014 machine. It was a very simple machine, and we can see this video game. Maybe it's so simple, but when that video was developed, it was advanced because executed Doom in the web was a process is wrote in C++ and transformed the code from one to the audio, and the threads are transformed to WebSockets, and a video that is already in a platform now can be in the web. So these are the advantages of full stack in many language: Rust, Go, Java, PHP, and more. And that's it. And you can say goodbye to JavaScript. Well, this is a joke. Of course, we will never replace one to the other. But don't wait. Go and enter WebAssembly all this is in the web. You can start writing the code and see how this is work. And what these are the links that I recommend through the browser. And later on, if you have these slides, review it again and you can learn how can start with this wonderful technology. Thank you. Thank you for being here. And hopefully you will start working with WebAssembly. And finally, participate in Mozilla Mexico Hispano.org.